Good evening. I'm glad you're here. Let the day ease off your shoulders like a coat set on a chair by the door. Settle into a comfortable spot and let the quiet gather around you like lamplight on a calm porch. Your breathing knows the way, steady, unhurried like a tide that never needs to hurry home. Tonight, we'll wander gently toward a rust-red horizon, where a small, patient planet circles the Sunday. People call it Mars, but think of it, for now, as a second shoreline, distant, dry, and full of careful questions. Could we live there? Could a human heartbeat find a rhythm under a thinner sky? We'll take our time, tracing the paths of explorers and engineers, listening for water hidden in the cold, and imagining homes that keep us warm against ancient winds. If these quiet travels help you rest, a soft tap on like and subscribe helps other sleepy minds find their way here, too. For now, keep the room dim, let your jaw loosen, and feel your thoughts drift weightless. When you're ready, we'll begin. The story of our reach beyond Earth began long ago, under the same quiet sky we still sleep beneath tonight. In the summer of 1969, when the world gathered around the glow of black and white screens, a single human footprint pressed softly into lunar dust. Neil Armstrong's voice floated across that distance, and for the first time, the line between dream and possibility blurred. It was not just a step, it was a breath of courage carried through the thin air of space. That small step whispered something ancient to us, that we are meant to wander, to stretch beyond the edge of our cradle. Now, decades later, another horizon waits, a colder one, red and wind-scarred, turning quietly around the Sunday Mars. The name itself feels dry on the tongue, like dust stirred by a faint breeze. Yet within that dust, something calls a reminder that the story of exploration never truly ended on the moon. Tonight, that story continues, softly and without hurry. In laboratories glowing with quiet light, on screens alive with shifting maps, and in the restless minds of those who still look up, the idea of touching Mars has moved from myth to method. Engineers speak of trajectories, scientists of soil, dreamers of homes built beneath pale skies. Strangely enough, we are now closer to setting foot on Mars than the world once was to touching the moon. The engines have grown steadier, the computers wiser, and the human heart still as curious as it ever was. To settle on another world, imagine that. A second home, rising from dust, the echo of humanity breathing within domes of glass and steel. It would be one of our species' greatest acts, not born of conquest, but of continuity, an act of survival and of hope, because Earth, beautiful and aching, is not invincible. Climate shifts, oceans rise, forests burn. Somewhere out there, fragments of stone wander in long orbits, reminders of the asteroids that once swept clean entire eras of life. We know how fragile the thread of existence can be, and perhaps that is why Mars feels less like escape and more like insurance, a quiet promise that even if the seas grow still, our story might continue beneath a different sun. In the past few years, the dream has gained new momentum. The discovery of vast amounts of frozen water beneath Martian soil has stirred a kind of quiet awe. Water means life, or at least the whisper of its possibility. Water means air to breathe, fuel to burn, crops to raise. And so, scientists have begun to map where that hidden ice lies, tracing future wells for future homes. Agencies like NASA and the European Space Agency along with bold private companies such as SpaceX, are already weaving their plans slow, meticulous, daring. But the road to Mars is not a straight line through space. It is a long, trembling bridge of unknowns. The journey alone takes 6 to 9 months, half a year, of drifting in a ship no larger than a small apartment, surrounded by emptiness and stars. Out there, radiation presses invisibly through metal hulls, and gravity loosens its hold on muscle and bone. Travelers will need to learn how to sleep in weightlessness, how to breathe in quiet cycles, how to dream without a horizon. And when they arrive, landing will not be gentle. The atmosphere of Mars is thin, too thin to slow a craft easily, too thick to ignore. Parachutes flutter half useless in that light air. Rockets must fire with perfect timing, and a single miscalculation can turn descent into silence. Those who step onto that rusted soil will stand beneath a sky of copper and pink, where the sun glows smaller and shadows stretch longer. They will look back toward Earth, a tiny spark among countless others, and feel the strange weight of distance. Mars is beautiful, but not forgiving. Its thin atmosphere cannot hold warmth. Its radiation would cook bare skin in minutes. Without a suit, human blood would boil, and lungs would freeze in the same breath. A colony there would need to live beneath layers of protection, rock, ice, or the very soil itself, to block the storm of cosmic rays that fall, unfiltered from space. Every breath, every sip of water, every moment of life would depend on systems built by human hands, sustained by care and precision. It is a delicate choreography of survival, a dance that cannot afford a single misstep. Yet in that fragility, there is something deeply human. We have always been builders in hostile lands, shaping warmth from cold, meaning from danger. The first settlements on Mars, if they rise, will be as humble and temporary as the first huts along an ancient river, but they will mark the moment we became more than earthbound. Our descendants may one day look back at that fragile beginning and see it as we see the moon landing the moment our species learned to breathe beyond its birth world. For as long as we have gazed upward, we have wondered whether we might belong somewhere else among the stars. From campfires to telescopes, from myths to missions, the question has remained, can we live beyond Earth? Among the planets, Mars has always been the one that felt almost reachable, almost familiar. Its valleys and volcanoes, its polar caps and dusty storms, all echo the shapes and rhythms of home. Scientists often say that if you squint at the Martian horizon, you might mistake it for a desert in Arizona or a red plain in Australia. The same wind-carved dunes, the same slant of light, different gravity, same longing. That resemblance has pulled us closer, mission after mission. Since the first blurry images from the Mariner 4 probe in 1965, we've watched Mars grow sharper in our collective imagination. Later, spacecraft traced its canyons, mapped its seasons, and found its clouds moving softly across pale skies. Each photograph deepened the feeling that Mars is not a stranger, just a distant cousin, lonely but waiting. In 1996, NASA began the Mars Exploration Program, a patient chain of robotic emissaries sent to learn the planet's secrets. They circled, landed, rolled across plains, and dug into dust. The first guiding idea was simple and elegant. Follow the water, because wherever there is water, there may have been life. Instead of hunting for creatures outright, scientists looked for the silent traces of rivers, the marks of streams long gone. Between 2000 and 2007, probe after probe found the geological echoes of ancient lakes and mineral veins, once carved by flowing water. The story began to shift. Mars was not always barren. It had once been blue. Then, as curiosity deepened literally, with the Curiosity rover, a new theme emerged: seek signs of life. The rover carried instruments to search for organic molecules, the tiny building blocks from which all known life arises. It landed in a crater that once may have held a lake, its wheels tracing paths through clay and sand, while cameras blinked against the ochre light. Around it, the landscape stretched quiet and endless, as if holding its breath. Somewhere in that stillness might lie the memory of life, not grand or visible, but microscopic, patient, waiting in the dark. In the years that followed, the European Space Agency joined with NASA on the ExoMars mission, adding new instruments to seek evidence of life, more directly to dig where sunlight cannot reach, to taste the hidden chemistry of the soil. The later Mars 2020 mission carried the Perseverance rover and a tiny helicopter named Ingenuity, the first machine to fly in another world's sky. Together, they began to gather samples, storing bits of Martian rock that might one day return to Earth. Each grain of dust, a time capsule from a world that could have harbored life before ours even began. As science moves, so does imagination. The third step of this long endeavor to prepare for human arrival has already begun. Designs for habitats, greenhouses, and return vehicles now fill blueprints and digital models. Some predict that in the late 2032, the first humans will set foot on the red planet. And when that moment comes, it will not be just another mission. It will be a turning of the page, a new chapter in a story that started the night Armstrong looked down at the moon and called it a small step. The urge to go further runs deeper than curiosity. It's stitched into our survival. Humanity has always expanded towards safety, seeking fertile ground when the old fields failed. The same instinct now looks upward. Space colonization isn't simply ambition, it's adaptation. Beyond Earth lie vast reserves of energy and materials, resources that could sustain life for millennia. Out there, we could build, breathe, and begin anew while giving our home planet time to heal. Some thinkers speak of this as a kind of ecological balance, Earth restored as a sanctuary, while humanity learns to live lightly among the stars. Others see it as destiny, the next step in evolution. Perhaps it is both. Either way, expansion may be not just desirable, but necessary. If a massive asteroid were to find our path again, if climate systems continue to unravel, our survival may depend on a second home. A colony on Mars could one day serve as a refuge, a seed kept safe beyond the reach of catastrophe. Even now, private companies are studying how to extract resources from asteroids, how to gather ice and minerals from the moon, how to build way stations in orbit, stepping stones on the path to a multi-planetary civilization. The European Space Agency's concept of a moon village imagines shared habitats, research labs, and mines under a soft gray dawn, all contributing to humanity's next migration. Mars remains the brightest beacon in that vision, the closest world where our descendants might wake under another sky and call it home. To think of it is to feel both wonder and humility. The same species that once feared the dark now reaches across it, guided by instruments finer than any compass, carried by courage older than language. Each rocket that rises through the atmosphere carries within it not just machinery, but memory of every explorer who ever watched a horizon and wondered what lay beyond. And as you drift toward sleep, picture it quietly, a dawn on Mars, the horizon tinted rose and gold, the first settlers stirring within their domes, breath clouds against glass. A garden hums softly under artificial light. Outside, the wind moves through dunes that remember no footsteps but theirs. In that stillness, the heartbeat of an entire species continues, slow and steady, echoing across the solar wind. Somewhere between Earth and Mars, between dream and distance, we are learning that survival and wonder can live in the same breath, that even in the vast silence of space, the human story still whispers forward, gentle and unbroken. And as that whisper travels farther, it begins to take shape, not as a question, but as an invitation. The next world waits in the rust-colored glow of dawn, a neighbor watching patiently from the edge of our imagination. Mars holds out its quiet hands, not as a promise of ease, but as a place where patience can root and grow. It offers more than the moon can give, a wider body to stand on, deeper stores of minerals, and a thin, workable breath of atmosphere that, with a little pressure and care, can coax green life to lift its leaves. The moon is a glittering bone, airless, fast to chill and fast to burn, while Mars is a colder cousin of Earth, austere but generous in a slow, practical way. Under the dust lie veins of frozen water, not a rumor, but a reservoir. Above the dust, a sky that, though thin, still holds a trace of weather, a memory of wind. That air, mostly carbon dioxide, 96 parts of every 100, with whispers of argon and nitrogen, is not friendly to us, but it is not nothing. Compress it and plants can sip it, split it, and oxygen emerges. Feed it with hydrogen from melted ice and methane blooms into fuel. The chemistry is simple enough to teach to a child, yet profound enough to anchor a civilization. Carbon plus oxygen for breath and combustion, hydrogen for heat and engines, nitrogen to knit the living tissues of crops. On Mars, these elements are present in workable amounts. On the moon, they are rare, brittle notes on a silent staff. That difference is the difference between an outpost and a home. Mars resembles us in ways that soothe the nervous system. A day there stretches only 39 minutes longer than ours. You can keep your watch, keep your rituals, drink your tea at dawn without lying to your sense of time. The sun arrives paler. Mars receives roughly 2/5 of the light that colors our noons, but it still throws shadows across stone, still wakes seeds inside warm glass. At the equator, when the planet leans and the air stills, the temperature can lift to a gentle 20 degrees Celsius, a small mercy under a wide sky. Night is harsher, but cold can be managed. It is the absence of pressure and the chemistry of the air that make the world lethal, not the frost alone. Gravity there is a soft hand, 1/3 of Earth's, strong enough to keep bones remembering their duty, light enough to turn work into a careful dance. We have learned from long months on the International Space Station that weightlessness is not freedom, but erosion. Muscles unbraid, bones release their calcium, the heart grows shy of effort. Mars offers a middle path where walking still means something and lifting still feels like work, where the body has a chance to settle into a new stride without forgetting what it is. These familiarities, dayling, gentle gravity, usable chemistry, fold together until the mind can imagine a self-sustaining place. Not a pristine Eden, but a lived-in home. Habitats tucked under mounded regolith to hush the radiation. Tunnels warm with recycled breath. Windows thick and small, showing a sky the color of copper tea. The hum of machinery replaces birdsong, but inside that hum, there is comfort. Oxygen generators sing softly in the background. Water loops through filters and membranes. 90% recovered, then more. Heat moves between rooms like a slow bloodstream. In one corner, a rack of LEDs pulses a mild dawn for basil and chard. In another, a small kiln bakes bricks from local dust, sintering the planet into walls. The first missions would be humble the way beginnings always are. Greenhouses might arrive folded like quiet secrets, unfurling under a pallid sun. Early crews would test soils, wash perchlorates from the grains, and plant cautiously. Nothing would be trusted at first. Shipments from Earth would fill the shelves, and homegrown harvests would be tasted as experiments, not relied upon. Then a second crew would prove what the first only touched. By the 10th, food would be local crisp leaves and small tomatoes, roots that carry the flavor of the ground and the water and the light that raised them. Bit by bit, the supply chain thins, until what remains is a lifeline for rare parts and new instruments, not staples. Outside the walls, the planet asks for respect in a dozen different tongues. The atmosphere presses at only a fraction of an Earth sea level breath, just a few millibars, so a torn suit is not an inconvenience but a final sentence. Carbon dioxide, the same gas that feeds plants so willingly, will smother a human body with swift and simple certainty. Dust moves with the softness of talc, yet cuts like glass. Its grains are fine enough to slip into seals and soils, reactive enough to worry the lungs, laced with salts that must be washed and tamed. The wind can rise without warning and then, just as suddenly, fall back into stillness, leaving the sky a muted bruise of color. Yet people learn. They always have. Filters get better. Airlocks gain second skins. Electrostatic fields shake dust from suits before the inner door opens. The abrasive grit that once threatened to grind joints into failure becomes a predictable nuisance, a chore to be done every evening, like sweeping a porch. Radiation, invisible and patient, is met with layers, meters of soil on top of sleeping quarters, panels of hydrogen-rich plastics, tanks of water arrayed like shields. Even the furniture becomes part of the defense, curved to deflect particles, arranged to shorten the paths through which energy passes. Energy itself is a daily ritual. Solar arrays stretch like dark lakes across pale ground, gathering light that slips through thin air with little scattering. Batteries yoke day to night. Small nuclear reactors, quiet and stubborn, hum beneath shielding when storms roll in and dust makes a ghost of the Sunday. Heat is not wasted. It's caught and reused, traded between rooms, stored in phase-change salts that melt and freeze like clockwork. The colony learns the planet's rhythms, the way our ancestors learned seasons. This much light at this hour, this much power by dawn, this much reserve before the wind rises. Landing there at all is its own slow miracle. A craft enters the atmosphere not to be caught, but to be managed. Parachutes can bite only so hard in such thin air, so rockets must do what cloth cannot. Supersonic retropropulsion engines firing into the onrushing wind turn speed into fire and then into stillness. We mastered a version of this ballet with the rovers, lowering them on cables like gifts to the ground. To set down people, and their houses and their tools is harder, but the choreography is known. Heat shield, drogue, main, cutaway, engines, dust, touch. The planet accepts what remains. Time itself becomes a tool and a companion. Launch windows open like flowers every 26 months or so, when worlds lean toward each other, just enough to make the journey brief. The trip takes half a year, sometimes a little more, and during that crossing the body learns to hold itself differently. Fluids rise toward the head, faces soften, spines lengthen. Exercise becomes a careful pact with the future. The mind adapts, too. Conversations home stretch out with a delay that can reach 20 minutes one way. People learn the elegance of messages. Say what matters, then listen, then wait. Loneliness softens into solitude. Solitude, tended well, becomes quiet strength. Inside the habitats, life organizes itself around cycles that feel familiar because they are. Mornings begin with checks and tea, and the sound of water moving through pipes. Days are for maintenance, research, the work of stitching a place tighter to human living. Afternoons spill into the greenhouses, where leaves reflect the light in glossy gradients, and pollinators, small electric helpers that hum faintly, move from flower to flower. Evenings belong to music and stories, and the long, unhurried talk that binds communities together. People trade recipes for soup. They argue about art. They remember rain and invent new words for dust. The ethics of it all hums beneath the machinery like a basso continuo. If Mars holds its own forms of life buried deep, slow as minerals, then the human urge to settle must include the humility to listen. Instruments reach into the ground, sniffing for organics, checking isotopes, asking old rocks what passed through them long before we were here to ask. The rules are careful. Do not contaminate what you hope to discover. Do not trample what you may someday understand. Planetary protection is not bureaucracy in this place. It is reverence. Beyond survival, the mind naturally wanders toward gentler futures. If Mars is so close to us in its habits, could it be coaxed closer still? The word for that is old now. Terraforming world, shaping the patient art of warming a planet until its air thickens, its seas reappear, its sky grows kind. The parameters that keep Mars austere, its cold, its dryness, its thinness of breath, are connected like the links of a chain. Tug one and the others move. Add warmth and the frozen carbon dioxide releases. Add atmosphere and the warmth holds. Add water and the planet begins to remember its rivers. There are ways to begin, all steady and slow. Vast mirrors in orbit could catch sunlight and pour it gently onto chosen regions, nudging the ground past a critical threshold where ice sublimates, where gases trapped for eons step out of stone and into sky. Synthetic greenhouse gases, carefully chosen molecules that trap heat more fiercely than carbon dioxide, could seed an artificial blanket, one that we intentionally wrap around a world that needs it. The first degrees of warming are the hardest. After that, the feedbacks begin to help. A small rise of 10 degrees might catalyze a larger rise of 50, as carbon dioxide and water vapor join the dance, thickening the air until the planet holds its own heat. With a thicker atmosphere, radiation softens. The brutal clarity of the sky hazes into a gentler light. Winds carry moisture farther. Meltwater explores old channels, tasting mineral beds that have slept dry for billions of years. Ponds bead and merge. Lakes find levels. If nitrogen proves scarce in the air, and it likely will, Then regolith and ice become the pantry, mines and chemical plants, the kitchens where missing ingredients are found and mixed back into circulation. Life follows nitrogen the way a melody follows a key. If we supply it, even carefully, the score can be played. The timescales involved are the length of epics. No one begins such work hoping to see its end. A mirror array takes decades to build. A sky takes centuries to thicken. A planet takes longer still to grow a weather all its own. There are even deeper ideas, placing a magnetic shield at a point between Mars and the Sun, so the solar wind no longer strips the upper atmosphere bare, but those, too, belong to the calculus of generations. Terraforming is less a project than a vow. We start so that others may continue. We continue so that others may arrive. The cost is high, and the patience required is steeper than mountains, but the outcome is a world that does not merely tolerate us, it cooperates. Until then, until the mirrors glint and the atmosphere loosens its collar, any settlement will rely on intimacy with the present Mars. The art is to use what exists and carry what does not. The atmosphere can be pressed into greenhouses. The carbon can be married to hydrogen, from melted ice to make fuels and plastics. Oxygen can be coaxed from carbon dioxide by solid oxide electrolyzers that breathe like mechanical forests. Water loops return 90+% of what they touch. Waste becomes feedstock in careful bioreactors, where microbes nibble and transform, turning scraps into soil and methane and heat. Nothing is trash in a closed world. Everything is a temporary arrangement. Construction itself learns the dialect of the planet. Regolith sintered into bricks under concentrated sunlight, glass made from local silica, roofs layered with soil so thick that cosmic rays must thread a labyrinth before they reach a bed. 3D printers lay material the way spiders lay silk line by line, curve by curve, until a dome stands where yesterday there was only dust. Where the ground permits, lava tubes serve as ready-made halls, already shielded, already patient, waiting for lights and air and laughter. Culture follows infrastructure as surely as evening follows afternoon. The colony invents holidays when supply ships arrive, songs for calm windows when Earth is high in the sky, quiet rituals for dust storms when everyone gathers indoors, and books are read aloud. The children who grow up there will learn to draw with a shorter crayon box, more rusts and ambers, fewer blues, but they will also gain new colors. The inside green of domes at noon, the phantom violet of auroras that sometimes wander across the upper air. They will jump higher without fear. They will collect pebbles from places named by grandparents who helped build the air they breathe. All the while, Earth keeps breathing too. The two worlds learn to support each other without taking more than they can give. Orbital depots feed the deep space vehicles. The moon becomes a workshop for fuel and metals. Asteroids donate their nickel and water to shipyards that never see a sea. Supply routes strengthen until they feel like rivers. Every 26 months, the tides align and new crews come, bringing seeds, tools, instruments, stories, leaving behind a little more permanence each time they go. The case for Mars is not that it is easy, but that it is possible. It is not our escape hatch. It is our apprenticeship in careful living. On a world where every breath is accounted for, waste becomes wisdom and restraint becomes joy. The technologies that keep people alive, their tight loops, gentle footprints, respect for limits, are the same tools that will heal the world that raised us. The exchange is beautiful. Mars teaches us how to live lightly. Earth teaches us why. If one day the atmosphere thickens and the temperature rises, if the salts wash out of the soil and the dust learns to settle as loam, then the work can change from survival to stewardship. Hardy microbes will go first, then the plants that can tolerate cold and thin air. Later, forests that drink a deeper sky. Engineers will listen to ecologists, and ecologists will listen to rocks. The goal is not to erase Mars, but to let it reveal another version of itself, a version that allows human skin to feel wind without fear, human lungs to draw breath under open light. The timescales are long enough to teach humility, but not so long as to forbid hope. Under an orbit of mirrors and a quilt of greenhouse gases, the planet might sigh, and then stir, and then speak. A lake near the equator might hold its water through an entire summer. A valley might wake to fog. Children might skate in winter on ice that is not carbon dioxide but water, clear and blue in the right light. They will not know the panic of the first airlocks. They will inherit the calm of a place that once tried to say no and then learned how to say yes. Even if that future never fully arrives, if Mars remains a careful, technological garden rather than a wild, breathing world, the effort will have mattered. A second cradle is still a cradle. A place where humanity can continue through storms and centuries is still a sanctuary, and the lessons gathered along the way, how to build with less, how to share with more, how to value a single leaf like a treasure, will travel back across the void and take root where oceans move and birds throw their shadows on rivers. So breathe gently now, as if the air itself is precious. Imagine the mirrors rising one by one into place, each a new moon, small and exact. Imagine a factory no larger than a house, exhaling molecules that trap warmth, only here, only for good. Imagine someone in a pressure suit kneeling in the dust to press a palm to the ground, testing for heat, for moisture, for the first hint that the planet is becoming easier to love. In the stillness after that thought, there is no need to hurry. The work is long, but it has already begun in the minds and hands of those who build and tend and dream. Between worlds, messages drift like paper boats across a dark river. On one shore, our blue home, fierce and living. On the other, a red world, learning how to host a heartbeat. The distance is real, but the connection is stronger. It is measured, not in kilometers, but in care. If you listen closely, you can hear the rhythm of both planets at once. The soft hiss of oxygen woven from carbon, the tiny click of a seed bursting open in warm water, the hush of dust settling after engines fall silent. A human voice counts down to sunrise in a place where sunrise once meant nothing at all. Through it all moves the steady pulse of a species, learning how to be gentle on a grander scale, taking only what it must, giving back what it can, discovering that even in the thinnest air, a future can still draw breath and rise. And yet, beneath that fragile rhythm lies a quiet threat, constant as background static. Some challenges do not shout. They arrive like starlight, patient, invisible, everywhere at once. Radiation is the soft rain that never stops on Mars, a rain of ghostly particles seeping through skin and bone, whispering to the very script of life. Without Earth's thick air or its magnetic shield, the Martian surface lies open beneath a sky that does not defend as fiercely. Galactic rays wander in from the wreckage of old stars, and now and then, the sun exhales sharply, a breath of fire scattering charged particles across the void. In that lightless storm, DNA falters, cells forget their instructions, and even hope must learn to protect itself. People who measure such things have sent instruments to listen. Orbiters and landers have counted units the way librarians count pages, millisieverts per day, hundreds per year, numbers that mean little until they are placed next to a life and a career. Measurements above Mars have shown doses far greater than those at low Earth orbit, where our astronauts circle under a partial shield of Earth's magnetic cloak. Stretch that exposure across a journey there, months of work on the surface, and the journey home, and the total draws near limits set to protect human futures. The risk is not a single dramatic event, but an accumulation, the way sand fills a vessel grain by grain. Yet, even in this, there is room for craft. Shielding is a kind of architecture learned from the habits of particles. Dense materials stop some radiation, but hydrogen-rich materials, water, polyethylene, the light plastics that pack many bonds per volume, do well against protons. Soil works too. Pile meters of regolith atop a habitat, and the high-energy intruders must thread a maze of atoms before reaching a bed. Water tanks can be arranged like a moat around sleeping quarters, a liquid wall that multitasks coolant by day, protection by night. In the heart of a base, a storm shelter can wait as a room with no view, lined and layered, stocked with books and tea, a place to ride out the rare tempests with patience rather than fear. Design turns risk into ritual. Dosimeters become jewelry, small, worn, quietly counting, reminding people to move work indoors after a time. Suits earn new layers that flex and scatter, and paths across the ground favor shaded trenches and built berms. Windows learn to be modest. Light enters through indirect routes, and when sunlight is needed for plants, it reaches them through fibers and mirrors, not wide panes. No one trusts chance alone. The colony treats the sky with respect, checking solar weather the way fishermen have always checked tides. And when the sun flares, a calm voice announces the shelter hours, like a church bell calling a town to safety. Protection is only one axis of the puzzle. Another is cost, and cost can decide whether dreams materialize or remain in the soft focus of bedtime talk. The arithmetic of spaceflight used to be cruel. In the old days, rockets were single-use fireworks, magnificent, precise, and disposable. Imagine an airline that discards the plane after each flight. The ticket becomes a talisman for the very wealthy. So the first necessity is reusability, not as a stunt, but as a habit. Boosters that rise, deliver, and then return to land on their own hot breath, turn scarcity into repeatability. Heat shields that take more than one fall, engines that thrive through many ignitions, guidance systems that teach yesterday's lessons to tomorrow's flights. Every reuse scrapes a layer of cost away. Then there is the trick of mass and propellant. The way a ship leaves Earth heavy with fuel, it will not need until much later. A different choreography offers relief. Launch a vehicle mostly empty, a bird with hollow bones, and feed it in orbit, tanker by tanker, until it grows able to cross the interplanetary gap. On-orbit refueling feels like a quiet miracle the first time it succeeds. Two machines embracing in weightlessness, swapping chilled propellants measured to fractions of a degree. The logistics are complex. Cryogenic fluids must not boil away. Pumps and valves must speak the same language. The dance must be slow and exact, but the savings ripple downstream into every plan. The chemistry that powers such voyages does not have to come only from Earth. On Mars, carbon waits in the atmosphere, oxygen in both air and ice, hydrogen locked in frozen water. Join them with electricity and patience, and propellant appears, the old Sabatier reaction, humming like a contented furnace. Carbon dioxide plus hydrogen becoming methane and water, then water splitting to free hydrogen again in a loop that never tires. Oxygen, heavy and necessary, accumulates in tall, cold tanks. Methane rests beside it, a simple fuel with a long memory of chemistry class. The result is independence. Ships that arrive can also leave, not as litter, but as lifelines, linking two worlds with round-trip tickets. The mathematics of costs, once dominated by the weight of structures thrown away, begins to include economies of scale and cadence. Build often enough, and parts that were once artisanal become standard. Fly often enough, and reliability becomes a curve that rises toward confidence. Maintenance becomes a list, not a worry. Launch with reusable rockets that come back to try again. Refuel in orbit. Make propellant on Mars. Choose fuels that are simple to produce and store across seasons. These are levers that, pulled together, turn a 10-figure per person fantasy into something a city might one day budget for a collective endeavor rather than a single lifetime's extravagance. Even with costs slashed and propellant brewed beneath a pale sky, one of the most delicate movements remains the same: getting down safely with the weight of real life aboard. Mars complicates the act of arrival. The air is too thin to cradle heavy craft the way Earth's does, yet too present to ignore. Heat blooms at hypersonic speeds, so the vehicle wears a shield that must survive fire-ablative materials that char and carry heat away, layered like bark that knows how to burn without dying. As speed falls, parachutes can bloom, but they grasp a tenuous wind. Ring sail canopies designed to bite hard must be sized and sequenced with care, or they will only flutter like petals in an empty breeze. What cloth cannot do, engines must finish. Supersonic retropropulsion, a ship breaking with its own thunder, turns dusk orange plasma into clean hover. Sensors map the ground below. Terrain relative navigation compares camera views to remembered maps. Hazard avoidance, LiDAR traces invisible outlines of boulders and slopes. A guidance computer, composed as a veteran pilot, selects a patch of safe dust and leans gently into it. The choreography is new at this scale. The largest payloads we have ever kissed onto Mars weighed less than a car. For people, for habitats, for the first true neighborhoods to cross the Gulf, the numbers change by an order of magnitude. 10 metric tons at first, then 20, then 30, and more. Parachutes alone will not be enough. Engines alone, fighting gravity and drag without the help of air, will waste precious propellant. The answer is a stack of techniques that overlap like shields, each taking part of the burden until the ground is close enough to touch. Practice refines nerve. Robotic scouts precede human crews, testing new heat shields and inflatable decelerators that bloom like halos, adding fake bulk to a craft so the air feels it sooner. Supersonic chutes open in clean sequences. Sky crane maneuvers evolve into sturdier cousins for heavier landers. The entry corridor, once a narrow thread the size of a city, becomes wider as navigation learns to lean into uncertainty, shaving error with better clocks and smarter stars. Safety stops being a wish and grows into a discipline, a list of tests that must be humbled by success again and again before anyone steps aboard with a heartbeat. All the while, the radiation waits, not offended by our attention, simply present, patient. So landing zones choose geology that helps places where overburden is easy to pile, where lava tubes rest like ready-made basements beneath the surface. Habitats sink themselves partially into ground, roofs crowned by soil and water tanks. Storm shelters hide near the center of each module, wrapped in materials that love hydrogen. Personal routines adapt. Time spent outside becomes a precious currency, budgeted with care. Gardens offer not just food, but medicine for the mind. Chlorophyll under warm light does something to a human spirit that no lamp alone can manage. Costs recede in the new math of habit. A booster flies, then flies again. Composite tanks learn to flex through cycles without complaint. Launch pads endure scorches the way anvils endure hammers. Orbital propellant depots become mundane like warehouses at a harbor. Schedules synchronize with the geometry of planets, so that every 2 years, a season opens that feels like monsoon. A rush of departures, a pause, then a rush of arrivals. And then the long quiet of settling in. Contracts no longer speak of miracles, but of service levels. The extraordinary becomes logistics. And still, the arrival remains a ceremony. A ship that has traveled for 6 months, warmed by reactors the size of a desk and lit by lamps that cycle through false dawns, leans into the Martian atmosphere and yields to physics like a dancer trusting gravity. Heat paints the sky in the craft's viewports. The shield takes its share of violence and is cast aside. Parachutes bloom like pale flowers. Engines carve columns in the thin air. Dust lifts in curtains, then settles on legs that have never before touched a world. Inside, someone exhale laughs, a sound that always happens when danger gives way to ground. There will be years when nothing fails, and years when several small things ask for more attention than planned. In those years, prudence builds redundancy. Power sources stack solar when skies are clean, fission when dust erases the horizon, fuel cells when either needs help. Heat moves through the base like currency, exchanged, saved, invested, where it yields the most comfort. Air loops lower their losses until each breath is almost perfectly remembered by the system that gave it. Water is pulled from rock by heat and from air by cold, condensed, filtered, remineralized, sent back through taps with a taste that is part glacier, part machine, part victory. Some inventions will seem minor until they save a life. A dust-repellent coating that refuses to hold onto talc-fine grains. A glove joint that never binds. A cheap, rugged dosimeter that chirps softly in a pocket when it's time to step inside. An algorithm that notices a pattern in solar weather and whispers days ahead that a storm might be coming, so people schedule their EVA earlier in the week. Each small safeguard grows into culture, and culture becomes the colony's true shield. None of this replaces the necessity of deep-pocket patience. Building a self-sustaining city is an act measured in decades and performed by many hands. It asks launch systems that repeat with metronome regularity, factories that hum without applause, and a supply chain that becomes as sure as a sunrise. It asks us to treat risk not as spectacle, but as a set of numbers we learn to shrink with craft. It asks more than money. It asks trust, cooperation, and a stubborn willingness to learn from each iteration without vanity. When night falls on Mars, thin twilight, long shadows, the work of the day softens into the quiet that first drew people to sleep with science in their ears. A base, lamplit and low, lies under a quilt of soil and water. People drift toward a common room lined with books, screens dimmed to amber, a view of the stars framed by a small, thick window. Messages from Earth have arrived. The delay has made their contents tender rather than urgent. Someone reads aloud, a note from a northern city where rain has fallen all week. Someone else shares the first taste of lettuce grown in a new hydroponic tray. The table talk touches, briefly, on a new design for an inflatable decelerator. Less mass, more drag, then returns to the quiet business of being alive together. In the morning, routines begin again. Sensors are checked. The sun is measured by arrays that pivot with their quiet servo heartbeat. If the weather above the sun is calm, a pair of suits will be signed out, visors polished, seals inspected. A short walk will become a long memory, footsteps in dust that stays marked for years. If the forecast mentions a flare, work moves indoors without complaint. A storm shelter makes a snug office, the best place for writing, for the kinds of thought that need listening walls. In such a place, survival and wonder continue to share a single breath. The brutal arithmetic of radiation is balanced by the poetry of a seed opening under pale light. The hard edges of cost curves are rounded by the soft repetition of reusable machinery, returning to work like a well-loved tool. The violence of atmospheric entry becomes a rite that ends in dust settling on polished legs, in the sight of a sky where two small moons wander like thoughtful punctuation marks. Every advance that drops the price of a kilogram to orbit, every test that teaches engines to land themselves in a gentle cloud, every success at moving cold propellants from one tank to another without waste, every meter of regolith piled over a roof, every refinement in the choreography of aeroshell, parachute, and flame pulls the future a little closer to the present. The result is not spectacle, but continuity, a corridor long enough for a civilization to walk through at a human pace. And when you listen to all of it at once, it sounds like a lullaby, sung by two planets in harmony. Earth carries the melody, oceans, forests, storms, and Mars adds a spare, insistent counterpoint, dust, stone, thin air, and the heartbeat of a species learning to be careful. Between them runs a river of light and metal, of messages and ships, flowing on a schedule set by celestial geometry and human patience. It is not a race, but an adoption. Not an escape, but an extension of care. Somewhere in that ongoing song, the numbers keep improving. Radiation exposure becomes a manageable rhythm with smarter shelter and gentler materials. The cost per seat falls from myth to math as boosters return like commuting birds, and orbital refueling grows as ordinary as stopping for air along a long road. Factories hum beside fields of LEDs, turning carbon air and frozen water into propellant, into promise, into tickets home. The art of descent, of falling with precision, learns to cradle heavier ships, mastering the illusion that difficulty can be graceful. Night deepens. The colony sleeps beneath its shielding, dosimeters resting quietly on a shelf. Out on the plains, a thin wind brushes the dust like fingertips over an ancient drum. Above, a ship drifts in orbit, tanks full, guidance systems dreaming in silence. And far away, on the blue world that taught us how to breathe, people look up, and for once, the distance between the worlds feels less like absence and more like belonging. When morning comes, a quieter question rises with the light. Where should we make our first true home? Choosing a home has always begun with listening to the land, to the angle of the sun, to the unspoken needs of breath and water. On Mars, that listening becomes more deliberate, almost devotional. A base cannot stand where wonder alone points. It must grow where survival nods in agreement. The terrain must teach us. The sky must feed us. The soil must offer what little it remembers of life. Water and oxygen are not luxuries here. They are the bones of staying. Ice hides beneath the red crust, like pale memory. The thin air carries traces of vapor that can be drawn down into frost. Minerals cradle old whispers of rivers that vanished but not forgotten. Even oxygen, the breath that would save us, waits quietly inside the very carbon dioxide that would take it away, a riddle solved by heat, current, and patience, as metal machines learn to breathe like trees. The map of possibilities stretches from pole to pole, each latitude speaking a different dialect of light. The polar caps offer abundance, made visible bright sheets and buried banks of water ice that promise drinks, crops, fuel, and shielding. They also carry a long shadow of night. For nearly half a Martian year, darkness lingers, and the sun keeps a low profile, leaving solar arrays hungry and habitats dependent on stored heat and steady reactors. It is a test of patience measured in seasons, and for a first settlement, it asks more endurance than a small crew may have to spare. Near the equator, another voice answers. Days are warmer, seasons gentler, the swing between summer and winter less severe. Sunlight arrives with more regular grace, and the ground shakes off cold more willingly. Yet equatorial soil is often drier, the simplest ice less ready to meet a shovel. Somewhere between these extremes, a compromise quietly forms. Mid-latitudes invite a different balance, enough sunlight throughout the year to keep panels honest and greenhouses bright, and patches of accessible ground ice that make water not a rumor, but a reachable resource. These regions can offer deposits that are not vast fields like the poles, yet are real lenses and layers that a drill can find and a heater can melt into a steady flow. Engineers trace circles on maps where elevation is low enough to lend a few precious millibars of air for landing, and where slopes and boulders won't argue with legs and wheels. Scientists overlay those circles with their own sites where ancient water once wandered, where rocks keep a diary worth reading, where the planet's past leans within reach of a careful glove. In the west of Valles Marineris, the largest canyon in the solar system cuts a continent's worth of memory into the crust. There, a place some call Noctis Landing sits where cliffs pull back and the world opens. The canyon walls stand like cathedral aisles on the horizon, yet the floor spreads broad enough to feel the sky. From such a place, Earth would rise into view with dependable regularity, a pale blue point for the eye to rest on and for antennas to hold. The ground is old, layered with stories of water and wind. Being down low brings practical gifts: more air above to help with entry, a touch more warmth, and the possibility of nearby caves or lava tubes where natural shielding offers ready-made rooms. The idea of waking each soul under that canyon light, working where geology writes in bold strokes, stirs both the scientist and the settler at once. And yet there is a paradox that lives just above the planet itself. Two small moons, Phobos and Deimos, circle Mars like commas in a sentence not yet finished. They are tiny. Phobos barely 14 miles across, Deimos only 7, dusty, ancient, their gravity so shy that a strong step becomes almost a leap. Their wells are shallow. Landing and leaving them uses little energy compared with the grip of the Martian surface. Each keeps one face turned to the planet below, tidally locked, like attentive listeners who never look away. From the Mars-facing side of Deimos, the round-trip time for a radio whisper down to rovers and back is only a little more than 1/10 of a second. Telerobotics would feel almost like reaching out a hand. Early crews could practice the cadence of interplanetary travel without asking the atmosphere to welcome them on the first try, living in a place that teaches orbital logistics, surface control, and patience, all while scouting landing sites below and relaying signals across a changing horizon. A way station in that quiet sky could become a rest stop not only for Mars but for the asteroid belt beyond, a small harbor anchored to a larger dream. Wherever the first neighborhood settles canyon floor, gentle, plain, or moonlit rock, the next question is shelter, not only from cold and dust, but from the soft rain of radiation that fills the sky without a magnetic cloak. The solutions must be honest, with both physics and feeling. Burying habitats under meters of regolith is practical and powerful. Soil eats energy, turning lethal particles into mere heat before they reach a sleeping chest. Lava tubes offer halls already carved by fire long gone, roofs thick enough to hush the storm of cosmic rays. But excavation is heavy, and heavy means costly. To bring the machines that can move that much ground asks many launches, many tanks of propellant, many careful landings. The first shelter may need to be lighter in its travel and cleverer in its materials. One answer glints with a kind of gentle logic. Build with water, because water loves hydrogen, and hydrogen is kind to bodies when radiation knocks. Imagine an inflatable frame unfurled on a flat patch of dust, its bones shaped by air, its walls waiting. Pumps hum and send melted ice into place around the envelope, laying down a shell of frozen protection so thick that particles lose their nerve. Ice becomes architecture, a dome that glows milk pale in daylight and deepens to blue when night falls, shielding by day and by storm, and breathing back to the settlement a sense of open space that underground rooms can seldom offer. Light arrives, veiled through the translucent walls, distributed the way a winter sky softens a window, easy on eyes and circadian rhythms, a kindness to sleep and waking. Inside, a scaffolding of struts and membranes holds warmth and pressure. Outside, the ice is the armor, grown from local water, repairable with heat and time, stored as protection when day is bright, and as reservoir when growth and fuel demand more. Such a dome makes a virtue of abundance. In many regions, just below the surface, water ice waits in quantities that surprise even those who study the planet for a living. It is near enough to harvest with modest drills and heaters, clean enough to cycle through filters into human use. A habitat that drinks from the ground and then freezes its shield from the same source decouples itself from the imports that sink projects before they begin. The translucency of the shell answers another quiet need. Day is not merely a function of clocks, but of light that changes tone and strength. People sleep more deeply when morning climbs through a gradient and diminishes into dusk, and plants, the green engines of oxygen and patience, set their chemistry by such changes too. In a world where so much must be engineered, it feels right to let sunlight do a small part of the work, as nature always has. Not every answer favors the open sky. Some designs propose habitats partially recessed, their roofs crowded with water tanks like shining stones, their flanks wrapped in bags of local soil that can be stacked like books. Others imagine a hybrid, a buried core for sleeping and storms, linked by pressurized passageways to an ice-lit commons where day can be enjoyed without a suit. In each case, the goal is the same: to make safety feel like comfort, to turn necessity into a place someone would choose to be. The best shelters are the ones that forget they are shelters and become homes. Site selection folds back into these choices like thread through cloth. If the base leans on ice for its shield, then the ground must offer steady supply. If it depends on sunlight for power and for the health of its people, then latitude and weather must permit a dependable harvest of photons through all seasons. If communication with Earth is part of daily work, then horizons and sky visibility matter. A canyon with wide shoulders becomes more attractive than a narrow gorge. A plain with low relief, more useful than a beautiful maze of mesas. Elevation is no small detail. Lower ground lends precious air for the ballet of landing, and a touch more warmth. Too low, and dust may settle where panels need to breathe. The conversation among planners and dreamers circles these points without a single verdict, because there is more than one kind of best. A pure science site aches to place instruments where time wrote its most interesting lines. A pure survival site craves flat safety and easy ice. The first settlement will likely be a compromise that respects both the place where humans can live well enough to do good science, and do good science enough to learn how best to live. As data grows denser and maps grow finer, the circles on paper shrink and shift until they overlap like a Venn diagram that finally sighs into a single shape. Beyond the walls, the work of making a life proceeds at human speed. Water melts into pipes and then into cups. Oxygen flows from machines that separate it from carbon dioxide and loops back through rooms where basil and wheat rise in stacked trays. Nitrogen, the quiet partner in air, is found in the ground and admitted to the mix so that lungs and leaves both feel at home. The chemistry of staying becomes routine. In the morning, someone checks a cold trap that has been patiently harvesting the thin moisture from night air. By afternoon, a mechanic replaces a filter that caught a week's worth of dust from the suit lockers. In the evening, a botanist stands under the ice-lit dome and turns a leaf gently between fingers, satisfied that the plant has found the day sufficient and the air kind. Far above, the two small moons keep their steady watch. Phobos races fast, rising and setting many times in a single sol. Deimos drifts slower, a dim companion at the edge of the sky. From their Mars-facing slopes, relay antennas could point constantly at both ground and ships, turning intermittent lines into a dependable fabric of communication. A crew on Deimos could guide drones over canyon and dune with hardly any delay, fingers on joysticks, eyes on screens, mind and machine almost in the same place. This is how the first drafts of settlement might be written: a foothold in orbit, then modules on the ground, then a rhythm between them, like mountains and valleys joined by rivers. In that rhythm, the elegance of the ice dome is not only symbolic, but practical. A structure that rides to Mars as fabric and unfolds as shelter reduces the mass that must withstand entry, heat, and landing shocks. Robots can assemble it before anyone breathes inside. When the first cardigan warm air flows into the shell, it will carry a scent that mixes new plastic, clean water, and the faint iron of the dust outside, an aroma that says a new room exists where yesterday there was only weather. As seasons pass, The outer skin can be thickened against storms and flares, patched where small stones from the sky leave their signatures, annealed by sunlight, redirected by mirrors, so the shell heals like ice always does when given time and attention. Underground options are never exiled from the conversation. They are companions. A tunnel offers a storm refuge that needs no explanation, a place where dosimeters grow quiet and sleep grows deep. The ice-lit commons offers the opposite, a feeling of being outdoors without risk, of seeing the dim blue of a filtered noon halo, the edges of a plant, and turn a table into a small island of summer. Together, they make a home that honors biology as much as engineering, because humans are rhythmic creatures. We need dark that is truly dark and day that feels like day. We need views that change, even if they change within walls. We need materials that answer to both physics and psychology. A shell of ice that carries the sun softly into a room, and a cave of stone that holds silence like a bowl, are both medicines, and a good settlement will keep both on the shelf. Where the base finally stands, it will do more than endure. It will learn. Sensors will sip the air and report when dust grows more alkaline or when moisture climbs before dawn. Seismometers will teach us how Mars turns and hums. Weather stations will watch the parade of seasons, the rise and fall of pressure, the ghost of fog that sometimes visits canyons, the pattern of winds that sculpt dunes like slow rivers. Each lesson folds back into the plan: where to place the next dome, how to angle the next array, when to plant a crop so that harvest falls before a gritty storm season. Knowledge becomes shelter as surely as ice and soil do. The beauty of the site will be felt in small ways first. The path from airlock to greenhouse will be chosen to keep boots out of the worst drifts. The view from a favored window will catch Earth at the hour when it climbs into the sky and looks like a question mark you already know the answer to. A bench will find its way under the most luminous part of the dome at local noon, because people are photosensitive mammals and sit where the light is kind. A child will tape a drawing to a pressure door, a canyon, two moons, a small dome like a pearl, and the picture will make the door feel less like a seal and more like a threshold. All of this, the calculus of light and ice, the compromise of latitude, the poetry of a canyon chosen for both science and shelter, the practicality of a pit stop on a tiny moon adds up to something that feels older than rockets. It is the human art of settlement, practiced under a new sky, the way we have always listened to land and adjusted our houses to its mood. We will read Mars for a long time before we claim to know it, and even then, we will keep reading. A base is not a flag, it is a promise to pay attention. When night deepens and the dome glows like a lantern, the base will breathe at a steady pace. Water will freeze and thaw in its pipes like patient lungs. The ice shell will creak softly as temperatures glide down and up again, a sound no different in spirit from a house settling after sunset on Earth. If you stand at the window and let your eyes adjust, you might glimpse the outline of a ridge far away, a dark signature against the sky where Deimos drifts. Under your feet, heat will rise from mats that remember the day and give it back as comfort. Behind you, the low murmur of an oxygen separator will carry on without drama, a domestic sound like a distant kettle nearly done. And when you sleep, the site will keep its watch. Instruments will tally dew in the cold traps before dawn. Antennas will turn their faces with slow grace toward a ship skimming overhead. Somewhere in a lab, a thin slice of hydrated mineral will release its story to a spectrometer, admitting the trace of an ancient lake. On a screen in the common room, Earth will glow in delayed conversation, and a message from a garden-lit kitchen thousands of millions of miles away will arrive and feel as present as a hand on your shoulder. The first home on Mars will not be a single perfect solution, but a braid of sensible choices: mid-latitude light with reachable ice, a shelf of canyon floor with a wide horizon, small moons as quiet tutors in the art of interplanetary travel, and a habitat that turns water into wall and sunlight into gentleness. The planet does not promise ease. It offers partnership. We bring patience, craft, and the willingness to learn. Mars offers materials, vistas, and time. Together, with care, they become a place where human breath can continue, where science can be practiced without hurry, and where the soft work of living can take root under an unfamiliar but welcoming sky. Living well on Mars asks for more than a good roof and thick walls. A home is a heartbeat, a set of quiet services that never falter, air that stays sweet, water that returns clean, warmth that answers the chill, light that coaxes leaves to open. The first neighborhoods will arrive with more than beds and tables. They will bring the tools that let a small society breathe, drink, cook, grow, and mend without constant help from Earth. Every system will be a circle. Every circle will be tight. The foundation is life support that behaves like a patient garden enclosed in metal. In the beginning, simplicity carries the day. Physico-chemical systems that catch, clean, and return. Used water will move through filters and membranes that sift out salt and grit, then meet oxidizers and UV to hush the microbes that wandered in. Humidity from breath and baths will condense on cool coils, drip into sumps, and rejoin the loop. Carbon dioxide exhaled into a room will be scrubbed by sorbents and fed to electrolyzers that split molecules the way a quiet lightning might oxygen to the tanks and ducts. Carbon to a different stream that can be married later to hydrogen and turned into useful fuel. These machines are not glamorous. They are the steady pulse behind every whispered conversation and every night of safe sleep. As weeks lengthen into months, the circle grows greener. Bioregenerative systems step in, not as decoration, but as partners. Plants become colleagues in the work of staying. Their leaves drink our carbon dioxide. Their roots release water back to the air. Their bodies become food that carries both calories and comfort. Greenhouses will hum with layers of life. Trays of leafy crops under LEDs, tuned to spectra that plants love. Towers of vines whose flowers nod under the attentions of gentle, engineered pollinators. Shallow bioreactors where hardy algae sip thin light and return oxygen at a pace no machine can quite match for elegance. Waste streams divide into what can be composted and what must be cracked open by microbes in warm digesters. In those vessels, scraps become soil amendments, methane, and heat, a soft chemistry lesson playing on loop. Reliability, not novelty, sets the tempo. The first crews will trust the physico-chemical spine because it is predictable and repairable with wrenches and patience. Filters can be changed, pumps can be replaced, seals can be tightened. But to reduce, resupply, and make a life that feels less like camping and more like belonging, biology will take more and more of the load. The colony's lungs will become greener each season, its drinking water clearer by design rather than miracle, its plates shaded by fresh herbs that taste of the place they grew. The rule beneath it all is simple and sacred. What arrives must stay, and what is used must return. Light, heat, and motion are the colony's other trinity, and they begin with the star that watches both worlds. Martian sunlight is thinner than Earth's, but not meager. At the equator in fair weather, the solar flux feels like a bright northern noon, enough to cast crisp shadows and fill panels with good work, enough for leaves to set their clocks and sugars. Inside the domes, LEDs will fill gaps when clouds and dust dim the day. Their glow is carefully chosen, more dawn than laboratory, respectful of human sleep and plant circadian rhythms. Outside, arrays unfold like dark lakes across pale ground, tracking the sun with slow grace, harvesting the sky's quiet river. Yet sunlight on Mars has its moods. Dust can rise and hang for weeks, painting the firmament the color of old tea and lowering the day's gift to a stubborn trickle. For the base to keep its calm, power must be a braid, not a single strand. A small fission reactor, steady as a metronome, will carry the colony through storms and night with a hum felt more than heard. Batteries will bridge shorter shadows. Fuel cells will sip stored gases and return electricity and water when asked. Thermal salts will take the day's excess and release it back as warmth when the long blue dusk arrives. Where geology allows, warm water hidden deep might one day be coaxed upward to turn turbines or feed heat pumps, geothermal promise that asks for patience and careful drilling. For a first foothold, the surety of a compact reactor paired with solar spread and honest storage will keep greenhouses bright and air crisp even when the wind is unkind. Energy is not only generation, it is choreography. Microgrids will route power like a wise librarian lends books where needed, when needed, with an eye to who asks next. Heavy loads run during bright hours. Freezers and thermal stores pre-charge before storms. Low-priority tasks yield to life support and medical equipment without complaint. Waste heat from reactors and electrolyzers warms corridors and soil beds. Nothing hot leaves a room without a job to do along the way. The colony learns to live by a gentle budget in which each kilowatt has a name and a purpose. Inside the greenhouses, the details matter because details become dinner. Martian regolith, helpful as structure, is unkind as soil until tamed. Perchlorates are washed out in patient cycles. Chemistry is balanced with minerals carried from Earth or recovered from local rock. Hydroponics and aeroponics reduce mass in water, letting roots dangle in nutrient mist or rest in flowing films that use far less than a poured bed would. The air is kept moving but not harsh, the temperature set to a mild. Living room calm, the light cycling through morning and evening tones so the mind and the lettuce both feel cradled by a day. Pollination becomes a craft. Tiny brushes, autonomous microdrones, or bumblebee analogs, suited for pressurized rooms and gentle work. A calendar grows on the wall that counts sprouts, trellises, and harvests in quiet celebrations. Waste is where a settlement proves its wisdom. Blackwater and graywater part ways at the source, one bound for treatment that removes what must never return, the other for polishing and reuse until it becomes the same clean drink that began the loop. Solid wastes follow different paths, plastics and metals back to printers and furnaces that grind and extrude, organics to digesters and composters that burble softly with microbial appetite. Measured out of those vessels comes biogas for a cooktop, compost for a bed of tomatoes, and a small rise in temperature that inches a room away from the chill. In a place where shipments are rare and mass is expensive, nothing is trash. Everything is a traveler in a long circle. Air management shifts from the starkness of enough oxygen to the kindness of comfortable. Carbon dioxide is not an enemy, but a dial. Higher near plant benches during peak photosynthesis, lower near bunks during sleep. Humidity is set where lungs are happy and condensation doesn't sneak behind panels. Trace contaminants, solvents from 3D print feedstocks, off-gassing from new fabrics. The perfumes of herbs are caught by charcoal and catalysts so that the habitat smells of clean air and dinner, not machines. Fans are quiet and redundant because silence is a medicine and airflow is life. Safety threads through all of it like a strong, invisible cord. Every critical system runs in pairs or trios. Every loop has a bypass. Every valve can be turned by hand if a motor sulks. Manuals are printed on paper as well as stored on screens because batteries have their own tempers. Tools are chosen as much for their fixability as for their performance. Spare parts are cataloged with the affection some people reserve for books. When something fails, and in any honest place, it will repair as both a task and a ritual, done slowly, with tea cooling on a nearby table, a conversation of patient hands. Over time, the balance shifts gracefully from metal to green. Physico-chemical backbones keep the air sweet and the water bright. Plants add flavor, resilience, and meaning. The small reactor is not a statement, but a steady friend. Solar spreads its dark wings whenever the sky allows. Storage catches the intervals. Perhaps one day, pipes sink deeper into the crust to draw steady heat upward, and the base learns a new way to stand warm against winter. Perhaps thin film solar coats the dome itself, sipping scattered light that dust leaves behind. Perhaps the colony grows large enough that waste heat alone fills most of what people want from a heater, the way cities on Earth grow warm from their own industry. Each of these steps is an addition to a chord that already carries the melody. Through it all, the tone inside the habitat remains the same, a quiet, domestic hum, a green smell near the trays, voices low and close in the evening, the sigh of an airlock cycling with unhurried confidence. The invisible machinery of survival becomes background, and life moves to the foreground where it belongs. Books, work, a shared meal, a child tracing the arc of Phobos on a window with a fingertip. In that scene, colonization stops being a headline and becomes a habit. Air, water, and waste close their loops until loss is rare. Energy becomes a braided certainty that can outlast dust and darkness. Greenhouses shift from experiment to pantry. Factories turn local air and rock into fuel, plastics, and bricks. The colony's needs are met by a network of circles so graceful that the mind can finally rest. And when rest comes, when the lights dim to a soft evening and the pumps purr, sleep feels like the safest technology of all. The original closed loop in which breath goes out, breath comes in, and tomorrow rises, thin and bright, over a world that is learning to keep us as kindly as we keep it. Communication is the invisible lifeline of any civilization, a thread of light and math that ties voices to distant hearts. On Mars, that thread stretches thin across a dark ocean of space, and every word has to cross a distance that light itself finds long. The planets dance around the sun on uneven paths, sometimes drawing close enough that a message may take just 4 minutes to arrive, sometimes drifting so far apart that even light, the fastest traveler we know, needs 20. There are moments when the sun steps between them entirely, cutting the cord for days, and the two worlds fall silent, not because they have nothing to say, but because the cosmos reminds them of the scale of their separation. In that silence, engineers work quietly to weave a better bridge. NASA and ESA have already laced the Martian sky with orbiters that double as relay stations, listening and repeating signals so that rovers and landers can whisper their discoveries home. Mars Odyssey, Mars Reconnaissance Orbiter, MAVEN, and their European companions have become a small constellation of listeners, an embryonic network humming in thin orbit. Their antennas translate binary pulses into stories, chemical hints of water, temperature readings from a dusty dawn, photos of frost catching light on dune crests. These satellites, like old telegraph poles in the wilderness, connect lonely machines to a waiting world. They will not last forever. Solar arrays degrade, onboard fuel dwindles, electronics tire, but their service lays the groundwork for what comes next. A relay web that belongs not just to exploration, but to settlement itself. A network that will keep a city on Mars in conversation with its birthplace. Real-time talk, the easy luxury of call and response, will not belong to this relationship. A 4 to 20-minute delay reshapes everything. Questions become letters, not dialogue. Urgency is replaced by patience. A colony on Mars will learn to think ahead, to compose messages that anticipate answers, to use silence as part of communication. When Mars slips behind the sun, as it does each synodic year, blackouts will come, total radio eclipses. Yet even this will be met with craft. Relay satellites positioned far from the line of conjunction, perhaps at gravitational balance points or in wider solar orbits, could bend the signal around the sun's glare. Networks designed to triangulate and repeat will make the blackout shorter, gentler, until one day it becomes only a momentary hush in an otherwise steady conversation between two planets that will feel like music, intervals and pauses, but always a return to the theme. Before any voice from a helmet echoes across a Martian plain, other voices, mechanical, electric, tireless, have already spoken. Rovers like Spirit and Opportunity, those twin wanderers who outlived every expectation, began the conversation decades ago. They tasted dust, watched the wind, scraped the rock for signs of ancient water. Curiosity came later, heavier, hungrier, its laser eyes and chemical sniffers learning to read the planet's weathered pages. Perseverance and its small companion drone, Ingenuity, turned exploration into choreography, wheels tracing paths and blades writing circles in the thin air. These early emissaries are not just scouts, they are apprenticeships, teaching us how to drive, drill, and dream in a place that does not care whether we stay. Once the data has built a map not just of terrain but of trust, where ice hides, how seasons shift, which storms sleep and which wander, a different kind of ship will arrive. Robotic cargo missions will come like patient traders, bringing modules, supplies, and machines years before any crew departs Earth. Their job is to build a foundation in silence, habitats to inflate, reactors to hum, water extraction units to wait like wells. Solar panels will unfurl, sensors will blink awake, and the red plane will slowly acquire order. Each cargo lander will add another piece: storage tanks, oxygen plants, greenhouse frames, maybe even the first small drills to test deeper ice. By the time a human voice speaks in the open air of Mars, the planet will already hum with quiet preparation. The first human base will likely be a research station, an international space station transplanted to solid ground. The idea of an international laboratory, built and tended by many nations, echoes through mission plans. Science will be its overt purpose, survival its deeper one. Inside its pressure hulls, experiments will study the dust, the radiation, the strange electricity of a thin sky. Outside, antennas will turn toward Earth, reporting each discovery through those long, delayed channels of light. The symbol will matter as much as the science. Humanity, united again under a sky that belongs to none of us, working where the old divisions of nations feel smaller than a grain of sand. NASA's Journey to Mars program gives that vision its formal rhythm. It is less a single leap than a long breath drawn in 3 parts. The first part, Earth-reliant, began in the familiar orbit of the International Space Station. Astronauts there have been the test pilots of duration, learning how bones thin, how fluids shift, how muscles negotiate with microgravity. They study closed-loop systems that reclaim water from every exhale, light that mimics day and night to guard sleep, diets that can stretch years without monotony. It is a rehearsal for living, where supply chains are measured in millions of kilometers and months of travel. The second phase, Proving Ground, moves the training outward beyond Earth's comforting magnetosphere into cislunar space, where the radiation is harsher and the distances begin to whisper of Mars. In this era, spacecraft will orbit the moon, perhaps visiting lunar gateways and testing propulsion, communication, and life support systems that must endure longer and fail less. Orion, NASA's deep space vessel, will lead the way. Larger than Apollo, built for months, not days, it can house a crew of 4 in modest grace. Its modular design allows docking with habitats, landers, and service units, a spacefaring apartment ready to connect to whatever neighborhood the mission requires. Early tests have already sent Orion around the moon without crew, checking heat shields and guidance under deep space conditions. Future missions will carry astronauts farther than any humans have ever gone, looping thousands of miles beyond the moon before returning home. These arcs in space are not symbolic detours. They are dress rehearsals for the rhythms of departure and return that interplanetary life demands. By the early 2030 seconds, the plan calls for the final act, Earth independent. This is the step where mission becomes migration. Humans will fly not to the moon, but into the orbit of Mars itself, a voyage of 16 months round trip. There, they will circle the red planet, close enough to watch sunsets stretch blue across the dust, far enough to test systems before trusting them to the surface. No boots will touch ground on that first journey. Safety and science will share the priority of survival. But orbit will offer a stage for learning entry and descent techniques by proxy, for rehearsing landing sequences with robotic stand-ins below. The orbiting crew will act as overseers, guiding autonomous landers and preparing the choreography that future crews will repeat, with their own hearts beating inside the helmets. Other nations, too, trace arcs toward Mars, each with its own timing and poetry. The European Space Agency's Aurora program speaks of continuity, robotic explorers like ExoMars paving a route for human steps. The 2016 mission sought organic signatures in the soil. The next will follow, refining instruments and methods. India's Mangalyaan probe, Japan's Nozomi, and a suite of Chinese and Russian designs continue the same theme, learning the world before living on it. China's Tianwen-1 and its Zhurong rover, Russia's ambitions for joint robotic and human exploration, all hum in harmony with the idea that Mars belongs to study before settlement. The timelines differ: the 2040 seconds, the 2050 seconds, but the direction is one: a quiet, deliberate march outward. Still, the clearest schedule belongs to NASA. Its journey to Mars is not an abstract slogan, but a chain of work already underway. Habitats tested for months in orbit, propulsion systems rehearsed, recycling technologies refined. In 2015, when the program was formally announced, it gathered all the disparate threads: robotic exploration, biological research, spacecraft design, into a single narrative. The story's end is not a flag or a footprint, but a community. Earth-Reliant taught how to live long without resupply. Proving Ground shows how to leave home and function without constant supervision. Earth Independent imagines people who can take those lessons and write their own manual of living under a different sun. The Orion spacecraft is the symbol of this continuity, a capsule reminiscent of Apollo, yet layered with new wisdom. Its heat shield carries composite materials built to withstand not just one re-entry, but many. Its avionics speak fluently with multiple systems, ready to talk to both lunar gateways and Martian transfer stages. The crew inside will have more room, more autonomy, and more time to think. 16 months from Earth to Mars and back again will be a meditation on distance. Every sunrise delayed, every message a memory before it arrives. These astronauts will orbit the red planet and see, perhaps through small windows or large digital panes, the valleys and volcanoes that have lived in textbooks for centuries. They will not yet descend, but their presence will mark the threshold between exploration and belonging. The machinery of communication will stretch to meet them, a long string of antennas and dishes tracing a curve from the deep space network's desert dishes on Earth to relay satellites near Mars. Light will flicker across millions of kilometers, carrying laughter, data, heartbeat, and news. The delay will still exist: 4 minutes, 10, 20, but by then it will feel like a natural rhythm, like breathing. Software will predict, buffer, and synchronize so that messages arrive at the right emotional time. Conversations will unfold like correspondence in an age rediscovered, each word chosen carefully, each silence understood as part of the reply. In parallel, the robotic work will continue below. Cargo landers will practice autonomous landings under watchful eyes in orbit. Sample return missions in the late 2020 seconds will bring back the first handfuls of Martian soil, sterile perhaps, or perhaps whispering of ancient chemistry still unfinished. Each success will narrow the gap between plan and place. When the orbiting crew finally returns to Earth, they will bring with them not only data, but the certainty that human presence on Mars is no longer an if, but a when. The efforts of many nations braid together here, a shared recognition that the frontier is too large for rivalry. Even if political winds shift, the collective memory of exploration has its own inertia. The European Aurora, China's interplanetary roadmap, Russia's joint mission proposals, India's steady orbiters, all feed the same current that runs through NASA's 3-phase plan. The milestones differ, the accents vary, but the direction remains outward. And so, communication, the theme that began this chapter, finds its reflection in every aspect of the enterprise. Between Earth and Mars, between agencies and languages, between the robotic past and the human future, The same principle applies. No one voice is enough. The first colony will be born not of conquest but of correspondence, of messages that took minutes or months to arrive, yet still built trust. The blackouts behind the sun, once feared, will be treated like holidays of silence, a time to listen to one's own planet's hum before the next transmission begins. When that first orbiting crew turns for home, the relay satellites will continue their quiet spinning. They will pass signals from rovers still working, from habitats waiting, from instruments sampling the thin, rusty wind. The delay will feel less like distance and more like breathing space, an interplanetary pause between syllables. And beneath those orbits, on the ground that has learned to keep its new guests alive, the hum of power plants, air recyclers, and greenhouses will join the music of communication, a steady background tone of life sustained across two worlds. One day, perhaps decades later, a descendant of that orbiting mission will open a hatch onto Martian soil. The signal of that moment will begin its long flight home. 16 minutes of silence, filled with history, photons carrying proof that the gap between planets has become a bridge. On Earth, somewhere in a quiet room, a technician will see a heartbeat trace across a monitor, and light from another world will paint their face. In that small flicker, humanity will have completed the first full sentence in its new language, a language of distance, patience, and the unbroken thread of communication between the world that made us and the one that waits. Beyond the ambitions of governments and space agencies, another kind of momentum is building the collective imagination of people who refuse to wait for permission from history. Some are engineers, some are dreamers, and many are both at once. They do not see Mars as an unreachable frontier, but as the next expression of something ancient in us, the instinct to move, to build, to plant a flag, not of conquest, but of curiosity. Among them is a constellation of organizations and private ventures that speak of Mars not as a distant sphere of light in the night sky, but as a future address. The Mars Society stands at the center of this constellation, a community of scientists, architects, and storytellers who have given themselves the task of making the red planet a livable thought before it becomes a livable place. Founded in the late 1992 and led by aerospace engineer Robert Zubrin, the Society builds and studies Mars analog stations in the deserts of Utah and the icy reaches of northern Canada. There, teams of volunteers practice the choreography of survival, donning suits, testing tools, timing airlocks, learning the rhythm of communication delay. The desert serves as both rehearsal and reminder. Its rust-colored soil, so like the Martian regolith, that one can forget, briefly, which planet the sun is rising over. Zubrin himself speaks of Mars with a conviction that borders on reverence. He argues that the technology already exists to reach and settle the planet. What is missing, he insists, is not machinery, but momentum. If the 1,960 seconds could carry humanity from John F. Kennedy's words to Neil Armstrong's footprint in less than a decade, then the 21st century, armed with digital tools and reusable rockets, could match that pace. We could see Mars colonization in our time, he often says, and in his voice, there's the unshakable rhythm of an engineer who has already run the numbers twice. His vision is not a temporary encampment, but a beginning, a city where human breath and Martian air find a common rhythm, That sense of urgency has found its loudest echo in the private sector, particularly in one company whose name has become shorthand for ambition: SpaceX. Founded in 2002 by entrepreneur Elon Musk, the company's mission statement reads like science fiction rendered as business plan to make life multiplanetary. Musk has never described Mars as a mere project. To him, it is a contingency plan for civilization itself, a seed vault for consciousness. Yet beneath that poetry lies a hard economic truth. The path to Mars must be affordable. The Apollo program, glorious as it was, cost tens of billions of dollars to deliver a handful of men to the moon. Replicating that model for Mars would mean that each seat costs a fortune, each passenger a national investment. To change that equation, SpaceX began where cost bleeds fastest: the rocket. Reusable rockets were once considered a fantasy of efficiency, but by 2015, Falcon 9 boosters were returning from the edge of space to land upright on barges like obedient pencils, blackened by fire, but ready to fly again. Every successful landing transformed spectacle into practicality. Where other rockets burned their remains into the ocean, these returned to their hangars, inspected and reflown at a fraction of the cost. Reusability cut launch prices by orders of magnitude, proving that a path to Mars might start not with new physics, but with old thrift. From these foundations grew the architecture of the Starship system, a fully reusable spacecraft designed to ferry cargo and crew beyond Earth orbit. Its stainless steel skin gleams under Texas sunrises, a retro-futurist echo of the rockets once painted in pulp magazines, now real and immense. The design combines a crew section capable of holding 100 passengers with a cavernous cargo bay beneath, able to lift over 100 metric tons to orbit and return for more. The ship's propulsion system, powered by methane and liquid oxygen, is deliberately chosen for its recyclability. Both ingredients can be manufactured on Mars. Carbon dioxide from the atmosphere and water from subsurface ice pass through the Sabatier reaction, yield methane for fuel and oxygen for breathing. The ship could arrive, refuel, and leave a closed loop that eliminates the tyranny of one-way trips. The numbers, when strung together, sound almost mythic. 1 million people transported over a century, 10,000 voyages. A population large enough not just to survive, but to evolve, to generate its own weather of art, science, and routine. Each flight carrying 100 settlers and their tools, each ship leaving behind the scaffolding of a growing city. The first crossings would take roughly 80 days, but advances in propulsion, more efficient engines, lighter tanks, optimized transfer windows could shorten the trip to 30 days to cross the gap between worlds, 30 days to leave behind the comfort of oceans and arrive under a salmon-colored sky that knows no sound but wind. Skepticism, of course, walks alongside hope. SpaceX's designs are bold. Their success depends on choreography, more intricate than any attempted before. Every rocket, every tank, every line of code must work flawlessly in an environment that punishes error. Musk himself has admitted that the game allows no half measures. You have to do everything right and roll sevens. Yet the steady cadence of test flights, failures that teach, triumphs that echo across the world shows a company learning in public, willing to burn metal and time in pursuit of reliability. The sheer persistence of the effort has already shifted the language of possibility. A decade ago, Mars was an after-dinner fantasy. Now, it is a line item in budgets, a prototype in steel, a countdown already started. Other ventures orbit this vision, like smaller moons. Blue Origin, with its motto, Gradatim Ferrociter, step by step, ferociously builds heavy-lift rockets aimed at long-term space infrastructure. Relativity Space experiments with 3D printed boosters that can be manufactured in weeks, not years. A host of smaller companies focus on the quieter essentials: radiation-hardened electronics, closed-loop agriculture, autonomous construction. Together, they form an ecosystem of ambition, a distributed laboratory for interplanetary life. The Mars Society, meanwhile, keeps tending its human-scale experiments. At the Flashline Mars Arctic Research Station, teams endure weeks of isolation, managing resources, communications delays, and the psychology of distance. Each simulation sharpens the art of living together under constraint. Food is rationed, water recycled, energy budgeted. Conflicts are managed through routine and humor. The lessons feed back into real engineering: how much space a crew needs for sanity, how color and light affect mood, how to design airlocks that feel less like coffins and more like doors. The future colony is built first in miniature, in these remote classrooms where mistakes are free and lessons are priceless. Some researchers outside these circles imagine even broader collaborations. International consortia could pool resources for early infrastructure orbiters for communication, fuel depots, and automated cargo lines. Universities might manage greenhouses whose harvests are data, not food. Private-public partnerships could handle everything from energy grids to medical systems. The boundary between agency and enterprise is already blurring. Mars will complete that merger. Survival there will not care about who paid for the bolt or who printed the valve. What will matter is whether the air is clean and the lights stay on. The timeline, viewed from Earth, looks both distant and close. 10 years for the first crewed flight, if luck and funding hold. 40 to 100 for the rise of a self-sustaining city, its domes glinting under twin moons. Some will call this optimism, others will call it destiny. In truth, it is both. The same species that learned to walk upright, that crossed oceans with wooden hulls and linen sails, now turns its gaze to a colder sea and builds vessels of flame. The economics of expansion are beginning to make quiet sense. As launch costs drop below the price of a small apartment, orbit becomes a workspace. As reusable rockets become routine, payloads can multiply habitats, factories, telescopes, gardens. Cargo flights to Mars will preface human ones, delivering oxygen generators, seed banks, prefabricated habitats, and autonomous diggers. Each landing adds infrastructure, power grids, communication nodes, workshops where settlers will print tools and repair what breaks. The first ships may carry only machines, but the machines will prepare homes for the people who follow. If the vision holds, the colony will grow not like a city built from blueprints, but like coral, layer by layer. Each generation of settlers adding structure and color. Greenhouses will spread like glass fields. Ice domes will glimmer with captured light. Roads of compressed regolith will connect habitat clusters, and rovers will glide between them on quiet electric treads. Communication towers will hum softly against a thin wind. At night, Earth will rise above the horizon, a blue lantern hanging low in the sky, and people will still pause from their routines to look at it, remembering that every dream begins with distance. Sometime far beyond the first landing, children will be born on Mars who have never seen an ocean. They will measure their age in souls instead of days and know the constellations from a new perspective. Their lullabies will speak of dust, devils, and domes of light. Their holidays will celebrate the launch windows that connect them to the world that birthed their species. What began as experiment will turn into culture, and the culture will anchor itself in the same ordinary miracles that define home everywhere: warmth, laughter, shared labor, the comfort of knowing that tomorrow will come. The Mars Society dreams of this. SpaceX engineers plan for it, and scientists across continents work quietly on the necessary miracles: closed ecosystems, radiation-proof polymers, fusion engines, greenhouses that teach themselves the seasons. In these overlapping circles of effort, humanity rehearses a truth that it has always known. Exploration is never the opposite of care. To go outward is to understand inward. To build elsewhere is to reflect on what must be preserved here. If all goes well, the next few decades will witness the threshold cross the first ship with people aboard, leaving Earth not for a loop around the moon, but for a world that spins under a weaker sun. They will arrive, step onto the dust, and look up at a sky that glows faintly pink even at noon. Behind them, through the comms lag, Earth will wait and listen. Ahead of them lies not a barren world, but a beginning. The settlement of Mars, once an idea painted in pulp and poetry, is drawing its first breath in steel and silicon. Whether led by nations, companies, or communities, the impulse is the same: to stretch the human story across the dark and find it still coherent. The task is vast, the risks deep, but the reward is almost metaphysical: to ensure that thought, art, and laughter persist even if one world falters. When the first Martian city lights its streets against the night and radio waves ripple outward, they will not only signal presence, they will signal continuity. Someday, perhaps a century from now, the two planets will watch each other like siblings, trading light across the void, Earth shining blue, Mars a quiet ember. Ships will move between them on predictable tides of trajectory, bringing news, goods, and people. Humanity will have written a new chapter in its long autobiography, one that begins with a whisper of plasma and ends with the sound of footsteps on dust. And if you close your eyes and imagine that moment, the red horizon, the faint hum of air scrubbers, a voice speaking from another world, delayed by minutes, but alive, you can almost hear the rhythm that has guided us since the first campfire: to go, to learn, to build, and to stay. Mars will not be a miracle. It will be a mirror. In its reflection, we will see the same species that crossed deserts and oceans, now crossing the silence between stars, careful, curious, and very much awake beneath a different sky. Let the thought settle there: Mars not as a miracle but a mirror, and soften the edges of the day. Lights dim to a warm hush, instruments sleep. Somewhere far above, two small moons drift like quiet commas in a sentence that can pause without ending. The blue of Earth is only an ember now, and even that ember is gentle enough to close your eyes to. Breathe in, slow and easy. Breathe out, as if your breath could join the thin wind moving over rust-red dunes. The long corridor between worlds grows softer, like a shoreline at night when the tide has nothing urgent to say. Engines go silent in the mind. Domes glow faintly and then fade. The last message crosses the dark and arrives right on time, just as you begin to dream. Starlight loosens into a slow river. Constellations slide past like lanterns carried down a quiet street. The story doesn't stop. It simply lowers its voice and keeps walking, careful and curious, beneath a different sky. Let your thoughts grow lighter than dust, your heartbeat steady as orbit, your breath a small companion to the night. If there is a door between waking and sleep, it opens now without a sound. Step through. The universe can finish the sentence while you rest.